Assalamualaikum warahmatullahi wabarakatuh and very good day. So now this is the final part for the chapter number 4 where we will discuss about the pipe and also duct flow. So pipe and duct flow, normally this device or this system will use to transport liquid or gases. For example, here we have a ventilation ducting system normally used for the air conditioning system. So if you want to draw the schematic diagram, so we just draw the simple cross section of the piping or ducting as shown in this slide. For example, so we have example number 1 and also example number 2. Simple schematic diagram. Okay, in terms of characteristics, so the characteristics of the for the pipe and also duct flow depend on the application. For example, so we have the water flow through the pipes in the furnace of the power plant. We have flow of refrigerant in a freezer, the flow in heat exchanger, the system that involves with insulated pipe or duct to prevent any heat loss or gain, and so on. Okay, so here we just have the generalized energy balance equation because there are many applications for the pipe and also ducting flow, pipe and duct flow. So here we just present the what I call the generalized energy balance equation for steady flow process that can be used. Okay, so the simplified energy balance equation depend on the application of the pipe and also duct system. Okay, example 4.12. The electric heating system used in many houses consists of a simple duct with resistance heaters. Air is heated as its flow over resistant wire. Consider a 15 kilowatt electric heating system. Air enter the heating section at 100 kPa and 17 degrees Celsius with a volume flow rate of 150 meter cubic per minute. If heat is lost from the air in the duct to the surrounding at a rate of 200 watt, determine the exit temperature of air. So as usual, draw this simple schematic diagram to describe the process. So here we have the heating element where we have W in terms of W electrical work, rate of electrical work, WE dot, and we have air enter the pipe, and the energy or the power that provided to the electric heater is equal to 15 kilowatt, WE dot equal to 15 kilowatt. And inlet condition in terms of pressure, P1 equal to 100 kilopascal, T1 equal to 17 degrees Celsius, and the volume flow rate V1 dot equal to 150 meter cubic per minute. And during the process, we have a rate of heat loss to the surrounding, Q dot equal to 200 watt, where this value is referred to the rate of heat that released to surrounding through the pipe wall. And we need to determine the temperature of the air at the outlet of the piping system after the heating process. Okay, based on energy balance equation for steady flow process for this pipe system, so we implement the general energy balance equation for the open system and also for the steady flow process. So for this case, we will have no Q in dot, no kinetic energy terms, no potential energy terms. So we don't have any W out dot, but we will have W in dot, which is referred to the electrical work, WE dot. Okay, so the remaining terms for the energy balance equation for this specific problem is W in dot plus total in M dot multiplied by H equal to Q out dot plus total out M dot multiplied by H. Okay, by referring to the parameter or data that given in the equation, so simplify or be specific, so make it the energy balance equation more specific. So we'll have W in E dot plus M1 dot multiplied by H1 equal to Q out dot plus M2 dot multiplied by H2. And as we know, due to the mass balance principle, so M1 dot will be equal to M2 dot. Okay, so we just use generalized terms, what I call for the mass flow rate, because the value is same. So we just take the general terms for the mass flow rate as M1 dot for both M1 dot and also M2 dot. So M in E dot minus Q out dot will be equal to M1 dot multiplied by H2 minus H1. So the first formula will involve the enthalpy change, or we can use what I call another equation based on the specific heat, because now the substance involved is air or gas. So we can consider the air as an ideal gas. So we can use any we can use any ideal gas equation. So for this case, the second equation that can be used is W in E dot minus Q out dot also equal to M1 dot multiplied by Cp. So Cp value normally given, multiplied by T2 minus T1. So we can use both equation. The first equation that involves with enthalpy, we can use the ideal gas of air table, where we have additional step if we want to use this equation, where first we need to determine the value of H1, okay, and then from when all the data from the energy equation will obtain, so we can get the value of H2. So from the value of H2, we need to implement this value to the ideal gas of air table to determine our call the value of T2, normally through the interpolation. However, if you use the second equation involved with temperature difference, M1 dot Cp multiplied by T2 minus T1, so we can obtain directly from the equation the value of T2. So for this problem, we choose the second equation. So W in E dot minus Q out dot equal to M1 dot multiplied Cp multiplied by T2 minus T1. So first we determine the value of a specific volume, V1, where we use the ideal gas equation. So V1 equal to RT1 divided by P1. So R value normally equal to 0.287 kilopascal meter cubic per kg Kelvin. And the temperature must be in Kelvin. So V1, specific volume, state number 1, at the inlet equal to 0.832 meter cubic per kg. So we calculate the value of specific volume because we want to determine the mass flow rate for M1 dot. Because in the question, data given is the value for volume flow rate. So M1 dot equal to volume flow rate divided by specific volume V1 equal to 3.0 kilogram per second. Okay, then substitute what I call all the value that we have in the energy balance equation. W in E dot minus Q out dot equal to M1 dot multiplied by Cp multiplied by T2 minus T1. Okay, so Cp value for the air equal to 1.005 kJ per kg degree Celsius. Okay, substitute all the value, so we'll get the value for T2, where T2 equal to 21.9 degrees Celsius. So that's all for chapter number 4. Here in this slide, I provide you various numbers of questions that you can make as your exercise, but this number of questions refer to the thermodynamic by Yunus A. Chengel 7th edition. Okay, so that's all for chapter number 4. I hope you will understand the content. So if you not understand, please don't hesitate to ask me during the live discussion or through the online platform and so on. Okay, that's all. Assalamualaikum.